Welcome to this explainer. You've built this incredible machine learning model, but getting it onto the Hugging Face Hub can honestly feel like a bit of an annoying technical hurdle. Today, we're going to demystify exactly how to share your work, putting the automatic API route head-to-head with the manual Git approach. Let's dive right in.
So, you trained a degree model. Now what? You've put in the grueling hours, right? Curating the data, tuning those hyperparameters, and finally getting the results you wanted. But leaving that fully trained model just sitting alone on your local hard drive, honestly, that's a massive missed opportunity.
As the Hugging Face documentation puts it perfectly, sharing models will help others, saving them time and compute resources and providing access to useful trained artifacts. Sharing literally multiplies the value of your hard work. It builds up the whole open-source AI community so we can all build on each other's successes.
Here's what we're looking at today. 1. The power of sharing. 2. The push to Hub API. 3. The Python repository class. 4. API versus repository class. And finally, 5. Mastering Git LFS.
Moving to Section 2, the push_to-hub API, the automatic transmission.
This method is fast, breezy, and super streamlined. It really just takes 3 simple steps to get your model onto the hub. First up, you just log in using your Hugging Face authentication token. Second, initialize your model and tokenizer right in your script. And third, simply call the push_to-hub method directly on those objects. Boom, it handles all the heavy lifting for you.
And actually, it gets even simpler if you're using the trainer API to fine-tune. You literally just set one single magic parameter, push_to-hub equals true, inside your training arguments. By doing that, the trainer automatically uploads your model to the hub every single time it saves a checkpoint during training. How cool is that?
This is exactly why we call it the automated transmission of uploads. Under the hood, it handles repository creation, pushes the model and tokenizer files directly, and it even goes ahead and generates a model card with your metadata and evaluation results. The absolute best part? Zero manual file handling. You don't have to lift a finger.
All right, shifting gears to Section 3, the Python repository class, the manual gearbox.
So if the API is your automatic transmission, the repository class is your manual stick shift. It's a dedicated class within the Hugging Face_hub library that manages a local repository in a completely Git-like manner. It essentially abstracts away some of the worst pain points of raw Git, while still giving you that granular local control you really need when you're trying to perfectly stage specific files. Instead of a magical background upload, you're actually following a traditional Git workflow right inside your Python script. You initialize a local folder with cloned_from, make sure it's up to date with a git_pull, save your files, stage them with a git_add, lock them in with a git_commit, and finally send them off with a git_push. So yeah, it gives you ultimate control before anything goes live to the world.
Section 4, API versus repository class. Choosing your tool. Let's put these two head-to-head.
So, which one should you actually choose? Well, the push-to-hub API is your frictionless route. It's totally perfect for continuous, integrated uploads directly from a training script, with absolutely no manual file handling required. But you'll want to switch over to the repository class when you need precise, manual control over your local clones and commit structures, assuming, of course, you've got a basic grasp of Git.
Finally, we arrive at Section 5, Mastering Git LFS, the heavy lifter. Now here is the critical climax where standard methods completely break down. If you try to bypass Git entirely and just use a simple HTTP upload, well, you're going to hit a hard wall. Your upload will fail entirely if your file is larger than 5 gigabytes. And let's be real, for modern machine learning models, you are hitting 5 gigs in the blink of an eye. There is literally nothing worse than a massive upload failing right at 99%.
Okay, so what about regular Git? Well, even a standard PyTorch_model.bin wait file easily exceeds 400 megabytes. Sure, that's technically under the 5 gig HTTP limit, but it is a massive outlier for standard Git, which, remember, was really just designed for lightweight lines of text code. Shoving a 400 megabyte binary file into regular Git completely bloats and breaks the system.
And that right there is exactly why Git Large File Storage, or Git LFS, is a strict mandatory requirement for Hugging Face model weights. It's this incredibly ingenious system designed to handle large files. Basically, it replaces them with tiny text pointers in your local Git tree, while quietly storing the actual massive file contents away on a remote server.
To actually use it, you have to set it up before you write a single line of repository code. First, you install the Git LFS package on your system. Second, you run Git LFS install in your terminal to initialize it. And third, and this is absolutely key, you use Git LFS track to specify your large file extensions, so Git actually knows to treat them differently.
But wait, here is a brilliant, time-saving shortcut straight from the Hugging Face docs. If you create your repository via the web interface first, it automatically configures Git LFS for you. Yep, it just places a hidden .git attributes file in the repo that already tracks heavy files like .bin and .h5. That one simple click saves you a ton of manual terminal configuration. Highly recommend.
So, what will you build and share with the world? You now know the mechanics behind the automatic API, the manual repository class, and the heavy lifting power of Git LFS. The infrastructure is no longer an annoying hurdle. It's just a tool in your belt. The open source community is out there waiting for your work. So, with those technical barriers completely gone, what are you going to build and share next?